I'm Mike Huckman at the BioBuzz Center, and I am privileged to welcome here Dr. Francis Collins, the head of the National Institutes of Health here at the Bio International Convention in San Diego. Thank you for being here, Dr. Collins.
It's great to be here. Bio is always a fascinating gathering of innovative, smart people.
So you've joined us coming fresh out of a session on the Accelerated Medicines Partnership.
Right.
And as much as Washington loves acronyms, in this case I think it's purposeful. It's AMP, because you want to amp up the effort.
And we want to amplify the ability to discover new drug targets. What is this about? It's actually been in the works, about 3 years in the planning process. What's the motivation? Motivation is failures in phase 2 and phase 3 continue to bedevil us. Mm-hmm. And most of those are because of lack of efficacy, which means that somehow the target that was supposed to work for that disease turns out not to. Many of those targets developed from cell-based ideas or animal models, but apparently not reliable enough when it comes to humans to be predictive of efficacy.
But that's not uncommon.
Not uncommon, but maybe we could, in the current scheme where we're getting an awful lot of human data, approach this in a different way. So for instance, genomics giving us, not in animals, but in humans, a long list of potential drug targets that we never knew about before, from things like genome-wide association studies. But there are too many of them. You can't sift through them. How do you actually place a $500 million bet on something when there's not a filter here?
Yep.
So AMP basically is bringing together industry science and academic science around the shared goal to take this moment of opportunity with all these new molecular pathways that are emerging, and try to figure out which of those are going to be most successful in terms of development of a new drug program. We had to decide what diseases to work on.
And those will be?
Those will be Alzheimer's disease, type 2 diabetes, rheumatoid arthritis, and lupus. And it took a while to settle on those, but that's where the company's interest was.
How did you choose them?
We had to have at least 4 companies interested in putting money on the table for any disease we were going to work on. So that pretty clearly defined which ones we were going to be able to do, and those were the ones where there was the greatest interest.
So Dr. Collins, that sets up my next question, because you've talked about the science piece now, and now you've pivoted to the money piece. But you talked about money from the private sector. Let's talk about money at the public sector. Government in particular, and funding for your agency, the National Institutes of Health. You need more.
Desperately. I mean, I have such a paradoxical existence. Every day, exciting science pouring out of laboratories that we support. Just breathtaking in the sweep of what's possible now. So, science has never been better, but the resources to support it have not been this bad in at least 50 years. We've lost in the last 10 years about 25% of our purchasing power for research, which means that an individual who's trying to get supported by NIH has the worst chance in history of actually being able to get their grant funded, about 16%. That's not sustainable. We're leaving all kinds of great science on the table. We have to figure out a way to turn that corner. It does motivate us, if we needed any more motivation, to build partnerships and to figure out how to do things with other folks who can bring ideas and money to the table. AMP is jointly supported by industry and NIH, but we should be doing that whether we were in a budget crunch or not.
What are the long-term consequences of that?
The longest term is, are we beginning to lose this generation of young scientists? I get emails every day from graduate students, postdocs, junior faculty, who are really wondering, is there a path for me, or should I give up and go do something else or move to another country? We are really at risk of that if we don't turn this corner very soon.
So I won't say it was when you were a young scientist, but when you were a younger scientist, back in 1989, you made a significant discovery, and that was the gene involved with cystic fibrosis. In the interest of full disclosure, one of my clients is Vertex Pharmaceuticals, which coincidentally, the day before we're talking here at the Bio International Convention, unveiled highly anticipated but positive data regarding a combination of treatments that were born out of the foundational research and discovery that you did. So first question is how gratifying is it to you to see this come to fruition?
Well, when I learned about that early in the morning 2 days ago, I almost jumped out of my chair because I've been watching this very closely. It's such a critical area to have a better answer for those 95% of people with cystic fibrosis who have this delta F508 mutation, to have something.
The most common
The
cause.
most common by far. That was the mutation we discovered in 1989 that we knew meant that we had the right gene. And I know so many of those people, and I've worked so closely with the CF Foundation over the years trying to encourage their creative ideas, and it's just so fantastic to see how they, working with Vertex, have come up with this advance. Obviously, those are 24-week studies. We want to see what's going to happen over a longer period of time, but the data looks really good.
24-week studies, but 25 years. 25 years since you made that original discovery. And I think that that's emblematic of the time and the effort and the money that it takes these days to bring something from the bench to the bedside.
And that's one disease, and there's 7,000 diseases out there that we now know the molecular cause of, and we only have treatments for about 500 of them. So this doesn't scale very well if it's going to take 25 years and cost hundreds of millions of dollars for every disease. We've got to learn from what was so successful for CF, and that's sort of coming back to where we were, bringing together, as we are doing with AMP, the science that's possible from industry's perspective, from academia's perspective, but taking advantage of a lot of these new technologies in genomics, in electronic health records that weren't there in 1989, but they're there now. Shorten the timetable, increase the success rate, get treatments in place for more of those people who are still waiting.
Dr. Francis Collins, congratulations on the great data and and thank you for the work that you did back in the day, and best wishes on the new adventure with AMP.
Thanks. It's a privilege to be here.
Thanks for being here at the BioBussin'.